Hello, I'm David Cantor, one of the founders and the head of MLPerf. I'm going to speak briefly with us about the MLPerf Client benchmark, one of our newest benchmarks that came out late last year. I'm pleased to speak on behalf of the organization and the working group chairs and the community that worked on this and brought this together. So thank you for taking the time to join us. So MLPerf is one of the MLPerf benchmarks. It's one of the newest ones. It is focused on measuring performance of PC class systems like the notebooks and PCs we're all using here. And it came out in December of 2024. So, under a month ago. So we just have the first release. It's really early access in some ways. So the goal is to get the benchmark into users' hands. And unlike other MLPerf benchmarks, I've previously talked here about training, about inference. MLPerf Client is actually an installable application. So anyone can go out and get it. We're looking to get feedback, learn how to improve. We started with one model and 4 different tests, and it is currently on Windows 64. There's 2 GPU acceleration paths, and it's CLI only, although we are looking to add a GUI in the future. And as with all of the MLPerf benchmarks, it's open source. It's available on GitHub. We will be adding in the future more hardware support, different platforms, and more tests and models, and a GUI. So, as I said, there's 4 tests in one model. We picked a large language model to be the model that we would focus on for the first release. Those, of course, have captured everyone's attention. DeepSeek earlier over the weekend being the latest example of that. So this is going to take in a text prompt and then produce a response. And, it gets used in many different ways. And so the tests represent different ways that it can be used. So we've got these 4 tests. We're using the reference model is LLaMA 2 7 billion. The data set we use is Open Orca. And it's a single stream benchmark. So what that means is we're feeding in queries one at a time and looking at the response latency. And that's the primary metric, right? Just as it would be if you're sitting in, your system and using it, right? So this is not a server.
Open Orca is the context that you use with the prompt? Is that?
Yeah, Open Orca contains, yes, is the prompts and it is also how we, yes, that's exactly right. And so the tasks that we have are the content generation, creative writing, and then both light and moderate summarization. And for folks who aren't familiar, I just wanted to walk through, tokens, right?
The MMLU score, do you want to go back to that for just a second?
Yeah. So one of this great question and prompt here. MMLU is an accuracy test. And so in all the MLPerf benchmarks, we want to measure performance, but we need the accuracy to be good enough. And so we use MMLU and a certain threshold there to determine what is accurate enough. And so that helps us ensure that the optimizations are generally valid. Right, and we have accuracy thresholds in all of the MLPerf compute benchmarks.
Right.
So,
there's that old saying that people say, like, close enough for government work.
Yeah, that's right. This is not intended to be a full production LLM, right? We're not in the business of doing that. That's someone else's business.
I think that's an important distinction.
Yeah.
Is this is within the community. We always have this better, faster, cheaper thing that's coming to market.
Yes.
This is the most impartial way to look through a lens, this particular lens.
Yes.
And so where would you say opinion begins and ends in deciding which, in that last lineup of what's fit for purpose in that cadence?
Sorry.
So why are we deciding on
MMLU.
Yeah.
Yeah, that's one of the industry standards measures of accuracy. And so we want to go with something that's familiar to folks. And again, we're not out here trying to produce a production chatbot. So
And is it fair to say that's not a vendor benchmark?
no, it is not a vendor benchmark.
Okay.
This is. Tokens are the currency of LLMs. You input tokens, right? Each token is, a fraction of a word, and then you get tokens out. So the reason why this is important is when you look at the workloads in here, each of them tends to take a different number of input tokens and produce a different number of output tokens. So even though you've got the same model, you're using it in different ways. Again, the prompts come from Open Orca, and the larger context lengths are, significantly more computationally intensive. We allow IHVs to modify the model to work on their devices. We start with LLaMA 2 7 billion FP16. And then we do allow down to 4-bit integer quantization, which we've seen being useful in various cases. But because of the impact on accuracy, right, we have this accuracy test using MMLU, just as we discussed. So we've got the Onyx runtime with Gen AI for DirectML for GPUs, Intel OpenVINO for Intel GPUs. We have JSON files describing the configuration for each supported vendor and the code paths and config options they recommend. And if you're interested, we have a reviewer's guide that we can make available to folks who want to play around with this.